this problem we're going to solve an exponential equation. We have 7 to the x plus 3 equals e to the x. Well, we might try to get the same base on both sides so that we could set the powers equal to each other. There's really no way we're going to be able to get 7 and e to be the same base in any nice way. So another trick that we can do is to take the log of both sides, but we'd like to do it in a way that we can get rid of one of these exponentials. So we're going to take the natural log of both sides, since e is the natural exponential and they have the same base. The natural log of 7 to the x plus 3 then will equal the natural log of e to the x. Now we have to be careful. We can't just always take the natural log of both sides because the natural log can't be taken of a negative or 0. But we know in both cases that these are never 0 and they're never negative, these exponentials. So it's okay to do that. The natural log of 7 to the x plus 3, using our rules for logarithms, this x plus 3 power will come out in front. So we'll have x plus 3 times the natural log of 7. Now here we're taking the natural log of e to the x. Since the base of the natural log is e, these cancel each other because they're inverse functions, and we just get x. Now we're going to try to isolate the x terms together, so we need to distribute. We'll get x times the natural log of 7 plus 3 times the natural log of 7 equals x. We're bringing this x over. X times the natural log of 7 minus x. And then we're going to bring 3 natural log of 7 to the other side, so we'll have minus 3 natural log of 7 on the right. Factor out an x. We'll have x times the natural log of 7 minus 1. Note that it's not 7 minus 1, it's the natural log of 7 minus 1. So this is separate. Equals negative 3 times the natural log of 7. We're going to divide both sides by this quantity in parentheses. So we'll have x is equal to negative 3, which is the natural log of 7, over the natural log of 7, we'll put that in parentheses, minus 1. We put that in parentheses to make sure we're clear that the minus 1 is separate from the logarithm. Now, this is an exact answer. If we wanted to get the approximate answer, we could put this in our calculator. We could also rewrite this in another form. Since we have a negative up here in the numerator, we could actually distribute that into the denominator and rewrite this as 3 natural log of 7 over 1 minus the natural log of 7. That also helps keep it clear that the 1 is not part of the natural log. If we do put this in our calculator, we'll get that the solution is roughly negative 6.172. Now that we've solved this exponential equation algebraically, let's move to our Smartboard interactive whiteboard and solve it using a graphing utility. We want to solve 7 to the x plus 3 equals e to the x. We're going to do that by putting the left side of the equation in y1 and the right side in y2, graphing and finding the intersection points. Go to our calculator, press our y equal to button. In y1, we'll put 7 to the x plus 3 power. Now notice we want x plus 3 to be the exponent, so we group that in parentheses to make sure we clearly have that as our exponent. We'll enter. And in y2, we put the right side, which is e to the x. And we're going to graph that on our standard viewing window between minus 10 to 10 in both directions. And we're looking for the points of intersection. So the graph of y1, and you see the graph of y2 coming through there. Looks like there might be an intersection point someplace in the middle here. So we're going to narrow our field of view down to this region. We don't need to look over here in the positive x's. We go to our window settings, and we're going to change our x-min to maybe negative 7, and our x-max to maybe negative 5. Keep our scale at 1 for now. We're also going to use another feature as our zoom fit option. Once we've set our x-min and max, we can use our zoom fit to adjust the y's automatically. So if we hit our zoom button, press the up arrow once, we get zoom fit, hit enter, and see what that graph looks like. Here we see the graph of y1, and we see the graph of y2 coming through, and here we can clearly see there's an intersection point somewhere near negative 6, which is in the middle. Because we're kind of close here on the lower end, we're going to change our y-min so we can bump this up just a little bit. So we'll go back to our window, just come down here to y-min, and we'll make that maybe negative 0.01. And graph that again. Here we have the graph of y1. You can see the graph of y2 coming through, and again we see that intersection point somewhere around -6. So we'll go to our calc menu, pick option 5 for intersect. First curve is y1, so we'll hit enter. Second curve is y2, hit enter again. And our guess, it actually looks like we're pretty close to our guess, so we'll just hit enter. And we see that we get an intersection point. It's roughly at -6.17. So we drag that over. Make that graph a little bit bigger. So using our graphing utility, we can see that the solution set for this equation will be -6.17.